Here's our next integral. We use the substitution u is equal to root 4 minus x. This implies that u squared is equal to 4 minus x, and 2u du is equivalent to minus dx. So if you differentiate this with respect to x, u with respect to x, we have 2u du over dx, but when we differentiate the right hand side, we have minus 1, rearranged to have 2u du is equivalent to minus dx. Make that equivalent sign. So, and also this, we can write that this integral now is equivalent to 3 into x, which is a rearrangement of this formula to give us 4 minus u squared, brackets, minus 2u du. That's the substitution for dx. We have minus dx here. We just multiply both sides by minus 1 to get minus 2u du as a substitution for dx. And we have u in the denominator based on this substitution. And we can go ahead now and write that this is, we'll take out the factors 3 and negative 2 to give us negative 6 integral 4 minus u squared du. You might have a different approach to rearranging this algebraically. Just check that you get the same result at the end. And now this gives us minus 6 4u minus u cubed over 3 at c. You can write a bit of rearrangement here and factorizing in the same step. We brought this into one fraction and then took out a factor of negative 2 to simplify it. 12u minus u cubed at c. Oh, at this stage we do have 3 in the denominator here. No, it was that's it's here in the denominator, and it was cancelled. There's a negative 6 to give you negative 2. Here we go ahead to write minus, again we factorize in minus 2u from this expression here. 2u, we have 12 minus u squared at c. And finally, we can write that our integral 3x over root 4 minus x dx is equivalent to, we bring the c in front. It's just conventional to write positive values at the beginning of your result. Minus 2, 8 add x, and followed by root of 4 minus x, and the constant, oops, nope, we'd already added the constant of integration in the front. And there you have it. Most of it is just algebraic manipulation, but you need to go through the steps to reassure yourself that you can follow. I'm Alistair. Thanks for watching. Hi, this time we're given the gradient function being 3x squared minus 5x add 1 and the coordinates of a point on the curve 0, 3. And we're required to find the equation of the curve. As we said earlier on, dy dx is our gradient function. This is equal to 3x squared minus 5x add 1. Now this implies that y is the integral of this function, 3x squared minus 5x add 1 dx. And so we have that y is equal to x cubed minus 5 over 2 x squared add x add c. And we're given when y is equal to 3, then x is equal to 0. So y is equal to 3, and this will be 0 cubed minus 5 over 2, 0 squared, add 0, add c. So we know that c is equal to 3. So our constant of integration is 3. So with our constant of integration being 3, this is the equation of the curve written in standard form. Alternatively, we could write this in the form 2y, so multiplying both sides by 2, 2x cubed minus 5x squared add 2x add 6. You might see your results are quoted in different books in either the standard form or this form, 2y equal to 2x cubed minus 5x squared add 2x add 6. Thanks for watching. I'm Alistair. Hi there. We're given the gradient function of a curve and the coordinates of a point on the curve, which is 1, 2. The gradient function is 3x minus 4. And we're asked to find the equation of the curve. And this involves finding the constant of integration. Now the gradient function is actually dy dx. And we have this is equal to 3x minus 4. Now this implies that to find y, we just have to integrate the gradient function 3x minus 4 dx. So we know that y now is 3 over 2 x squared minus 4x add c. Well, we're given the coordinates of the point on the curve, which is 1, 2. So when x is equal to 1, y is equal to 2. So when y is equal to 2, x is equal to 1. So we'll substitute x equal to 1 into this equation. We'll have 3 over 2, 1 squared, minus 4 times 1, add c. And so we have that c is equal to 4 over 2 minus 3 over 2 add 8 over 2, which is equal to 9 over 2. So our constant of, let me just write this clearly, 9 over 2. Our constant of integration is 9 over 2. And now we could go ahead and find the equation of the curve. So our equation of the curve is we substitute for c in this equation. We have 3 over 2 x squared minus 4x add 9 over 2. So this is in standard form. But alternatively, you can write it in a non-standard form. We multiply both sides of the equation by 2. Okay, by 2y is equal to 3x squared minus 8x add 9. Just a neat way of writing it by removing the fractions. So it's either this form, the standard form, or the non-standard form, 2y equal to 3x squared minus 8x add 9. Thanks for watching. I'm Alistair. Hi, how do we go about integrating this algebraic fraction? Well, first we'll rewrite this using partial fractions. So this now is equivalent to the integral of 4, and it'd be a good exercise. We have a difference of squares here, so it's x minus 5 for this one, and we have minus 3 for the next constant. X add 5, all of this dx. Good exercise for you to check that you can decompose this into partial fractions and get the constants 4 and negative 3. And now we can go ahead and integrate this, get 4 ln x minus 5 minus 3 ln x add 5, add our constant of integration. So here key is to see we have a difference of squares, and then we can break that down into x minus 5 times x add 5, and we apply the method of finding partial fractions with the constants a being 4 and b being negative 3, which allows us to integrate this and obtain the result. Thanks for watching. I'm Alistair. Hi, for this integral we'll use the substitution x equivalent to 2 sine theta. This implies that dx is equivalent to 2 cosine theta d theta. Now when x is equal to 0, we have that sine theta is equal to 0. That means theta is equal to 0. And when x is equal to 1, the upper limit, we have that sine theta here, when we substitute in here, is equal to a half, giving us that theta is pi over 6. So now we can rewrite our integral as 0 to 1 over 4 minus x squared raised to the power 3 over 2 dx as the integral 0 to pi over 6, and we have 1 over 8 cosine 3 theta 2 cos theta d theta. I will simplify or explain how I got 8 cosine cube theta a little later as I go with the flow here. Now if we simplify this, we cancel the 2 with the 8, so we have a factor of a quarter, and also we have here a cosine theta. We'll cancel with this cosine cube theta to give us cosine square theta. So now we have 1 over cosine square theta d theta. which is the same as sec squared theta. So in the same step, we can write sec squared theta instead, d theta. And when we integrate this, we now have tan theta, and now this, not the integral sign, sorry, we have now that this is tan theta raised to the power pi over 6 and 0. This evaluates to give us a quarter. We have 1 over root 3 minus 0. Finally, our result is root 3 over 12. Coming up next is how I arrived at 8 cosine square theta. This one we'll use the substitution u is equivalent to x add 1. We'll express the denominator in completed square form, and this is equivalent to x add 1 squared add 1. And so now we can write problem as x squared at 2x add 2 dx equivalent to integral of 1 over x add 1 squared add 1 dx, which is the same as the integral of 1 over u squared add 1 du, which is arc tan u add c. And we substitute now for u, which is x add 1, and the constant of integration. Thanks for watching. I'm Alistair.